In this lesson, you will learn what window functions are, how to write queries using window aggregate functions, how to write queries that use window ranking functions, what window distribution functions are, and how to write queries that use window offset functions. Let's first see what windows functions are. A window function is a function applied to a window or a set of rows. Earlier in this course, you learned about group aggregate functions such as sum, min, and max, which operate on a set of rows defined by a group by clause. In window operations, you can also use these functions as well as others to operate on a set of rows defined in a window by an over clause and its elements. SQL Server window functions can be categorized as aggregate, ranking, distribution, and offset functions. Aggregate functions such as sum operate on a window and return a single row. Ranking functions depend on a sort order and return a value representing the rank of a row with respect to other rows in the window. Distribution functions calculate the distribution of a value in a window of rows. Offset functions return values from other rows relative to the position of the current row. And when used in windowing scenarios, these functions depend on the result set returned by the over clause and any other further restrictions you provide within the over clause, such as partitioning and framing. Let's take a quick look at an example. In this example, the query uses the rank function to calculate a rank of each row by unit price. And since we are ordering the unit price in the descending order, the ranks will be high to low. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. The ranks are dependent on the unit price ordered in the descending order. And as you can see, there is no partitioning in this query. Now let's add a partition on the category ID and see what the results will look like. Partition by category ID, and let's add the category ID to the order by clause also. Before we execute this query, let's also add the category ID in the select clause. Let's click on Execute, and as you can see, the price ranks are dependent on the category ID as well as the unit price. The addition of the partitioning allows the window functions to operate at a more granular level than when over returns an unrestricted set. When the category ID changes, the price rank is reset and is calculated for the next category ID. So in the category ID 1, all the ranks 1 through 12 are calculated, and then for category ID 2, the first product, which has highest unit price, is again ranked as 1. When you look closely at the result set, some of the ranks are repeated. Repeating values and gaps in the price rank column are expected when using rank in case of ties. You need to use dense rank function if gaps are not desired. Now that we have seen how window functions work, let's take a look at some of the window aggregate functions. Window aggregate functions are similar to the aggregate functions that you've already learned in this course. They aggregate a set of rows and return a single value. However, when used in the context of windows, they operate on the set written by the over clause and not on a set defined by a grouped query using the group by clause. And these window aggregate functions provide support for windowing elements that you've learned about in this module, such as partitioning, ordering, and framing. Ordering is not required with aggregate functions, unlike with other window functions, unless you're also specifying a frame. Let's take a look at this example. In this query, it uses the sum function to display the total quantities per customer as a separate column. First, let's execute this query and see what the results will look like, and then we'll manipulate this query to make it more useful. Let's open a new query, paste the query that we just saw, and click on Execute. It will display the customer ID, the order month, the quantity that the customer placed in that month, and the total per customer. Now let's change this query a little bit to get the ratio of each sale to the total per customer. Let's add a new column. And let's use the cast function 100 into quantity divided by the sum of quantity over partition by customer ID as numeric and let's call it of total. Let's execute this query. And as you can see, this new column determines the ratio of each sale to the total per customer. Similarly, you can use all the other aggregate functions in windowing context. Now that we've learned about window aggregate functions, let's see what window ranking functions are. Window ranking functions return a value representing the rank of a row with respect to other rows in the window. To accomplish this, ranking functions require an order by element within the over clause to establish the position of each row within that window. But the order by element within that over clause affects only the processing of rows by the window function. To control the display order of the result set, you need to still add an order by clause to the end of the select statement. Let's see some of the window ranking functions that SQL Server supports. The rank function returns the rank of each row within the partition of a result set, and it may include ties and gaps. The dense rank function returns the rank of each row within the partition of a result set, and it may include ties just like the rank function, but it will not include gaps. The row number function returns a unique sequential row number within the partition based on the current order. The end-tile function distributes the rows in an ordered partition into a specified number of groups and returns the number of the group to which the current row belongs. Let's take a quick look at an example to see the difference between rank and the dense rank functions. Let's open a new query. Let's expand the databases, expand T-SQL 2012. Let's go to the views and let's do a simple select to a new query editor window. Now let's add the rank function and the dense rank function to see what the results will look like. Let's use the over clause and partition by the category ID, and let's order by unit price in the descending order and call it price rank. Now let's use the dense rank function over partition by category ID and order by unit price in the descending order. And let's call it dense price rank. Let's execute this query, and as you can see, when there is a tie in the unit price, the rank function and the dense rank function both display the same rank, but using the rank function, the next rank is 8 instead of a 5, so there is a gap in the numbers. But when using the dense rank function, the numbers do not have any gaps. And as discussed earlier, the order by clause in the over does not determine the order in which the final results are displayed. Now that we've learned about the window ranking functions and the differences between rank and dense rank functions, let's see what window distribution functions are. Window distribution functions perform statistical analysis on the rows within the window or window partition. Partitioning a window is optional for distribution functions, but ordering is required. Distribution functions return a rank of a row but instead of being expressed as an ordinal number as with rank, dense rank, or row number functions, it is expressed as a ratio between 0 and 1. The distribution functions that SQL Server 2012 supports are percentile rank and cumulative distribution. It also adds window inverse distribution functions, which are percentile using discrete distribution model and percentile using continuous distribution model. The last two are implemented as window functions and not as grouped ordered set functions. Now let's see what window offset functions are. Windows offset functions enable access to values located in rows other than the current row. This can enable queries that perform comparison between rows without the need to join the table to itself. Offset functions operate on a position that is either relative to the current row or relative to the starting or ending boundary of the window frame. And some of the SQL Server window offset functions are lag, lead, first value, and last value. The lag function returns an expression from a previous row that is a defined offset from the current row. It returns a null if there is no row at the specified position. The lead function operates similar to a lag function, but it returns an expression from a later row that is a defined offset from the current row. It also returns null if there is no row at the specified position. The first value and last value functions return the first and last value respectively in the current window frame, and they require window ordering to be meaningful. Since first value and last value operate on offsets from the window frame, it is important to remember to specify framing options other than the default of range between unbounded preceding and current row. Which means for the last value function to return something other than the current row, the framing needs to be set such as to unbound following, which will then include all subsequent rows in the window frame. Now let's take a look at some examples of the window offset functions. Let's open a new query. And let's say you want to compare year-to-year sales of each of the employees. You can do that by using the sales.employee orders view. And let's do a simple select employee ID, the year of the order month column, and let's call it order year, and then the sum of the number of orders as current sales, and let's use the lead function, and let's say sum of the number of orders 1, 0 over partition by employee ID and order by the year as next year sales. From employee orders view, let's group this by employee ID and the year of the order month and sort the results by the employee ID and the order year. Let's execute this query, and as you can see, the current sales and the next year sales are displayed next to each other. And since the offset is 1, as mentioned here, it returns the next row's value in the next year sales. And when there is a null, because there are no sales in the next year for that employee ID, it displays a 0. Now let's change the lead function to lag and call it last year sales and click on execute to see what the results will look like. And as you can see, the results are in the reverse order when compared to the lead function. Now that we have seen how to use the window offset functions, let's recap what we've learned so far in this module. We have learned the benefits of using window functions, and how to restrict the window functions to rows defined in an over clause, including partitions and frames. We've learned about the T-SQL components used to define windows and the relationships between them, how to write queries that use the over clause with partitioning, ordering, and framing to define windows, and how to write queries that use the window functions like aggregate, ranking, distribution, and offset functions. In the next module, you will learn how to use pivot and unpivot operations to change the orientation of data from column-oriented to row-oriented and back, and then also learn how to use the grouping set subclause of the group by clause to specify multiple groupings in a single query.